I'm tackling a problem where my Sklearn SGDClassifier keeps predicting the majority class, no matter the input. Let's figure out why. The hinge loss is used for support vector machines, SVMs, and it's related to the SGDClassifier. However, I don't think it's the main reason for always predicting the majority class. I need to look at other factors. A large alpha means strong regularization. Regularization reduces the model's complexity to prevent overfitting. However, a value that's asterisk too large will make the model overly simple. It'll essentially ignore the data, leading to simple majority class prediction. That's a key insight. If I have way more examples of one class than the other, and I don't adjust for it, the model will focus on getting the majority class right. It will achieve better overall accuracy by ignoring the minority class. This is another important factor. Highly correlated features can create problems, making it difficult for the model to learn. It might contribute to poor performance, but I don't think this alone will always result in predicting the majority class. This section guides my investigation of each option. It's a step-by-step analysis of the potential reasons for the model's failure. This section outlines my plan. I will examine each possibility systematically. Alpha, regularization strength, class imbalance, and feature correlation to determine the root causes. This describes the core problem. My SGDClassifier model, a type of machine learning model used for classification, keeps predicting the most common class, ignoring the input data. It's like always guessing heads when flipping a coin, regardless of how the coin actually lands. Very large alpha means I'm using strong regularization. Think of alpha as a dial controlling how much I simplify my model. A large alpha forces my model to have small weights, essentially ignoring the features and defaulting to the majority class prediction. It's like oversimplifying things to the point of being useless. Imagine training a model to detect rare diseases. If most of my data is about healthy people, majority class, my model might focus on accurately predicting that, even if it sacrifices its accuracy when identifying rare diseases, minority class. That's why class weight balancing helps. It gives the model more weight to the minority class data for proper training. Without it, I'll just predict the majority class most of the time. The hinge loss is a function used in support vector machines, SVMs, which are related to SGDClassifier. While a poorly configured hinge loss could affect performance, it's unlikely to cause the consistent majority class prediction by itself. It's more of a supporting player, not the main culprit. High feature correlation means multiple features convey similar information. This can make it tough for the model to understand which feature is truly important. While it can reduce performance, it won't directly force majority class predictions. Think of it as a hurdle, not a direct cause of the model's issue. I'm looking at a problem where my SGDClassifier model, which I use for classifying data into two groups, keeps predicting the same group, the majority class, no matter what the input data is. This isn't good. It means the model isn't learning anything useful from my data. Let's find out why. I'm training a SGDClassifier model, a type of machine learning model, and it's not working correctly. It only predicts the most frequent category in my dataset, which isn't helpful. I'm trying to figure out what is causing this failure. If I set the alpha parameter, which controls regularization strength, too high, I'm essentially telling the model to drastically simplify itself. This leads to a model that ignores most of the features and defaults to the easiest option, constantly predicting the majority class. It's like saying, I don't care about the features. I'll always guess the most common outcome. If my data has a huge imbalance in classes, way more examples of one group than the other, and I don't use class weighting, I'm teaching the model to be biased. My model focuses on minimizing errors overall, so it's easier for it to always guess the majority class, even if it's wrong a lot of the time for the less frequent group. It's like having a test with 90% of the answers being A. A simple model would just guess A for everything, even if it's not always right. The loss parameter, hinge, here, which is a loss function used in support vector machines, SVMs, which are related to SGDClassifier, isn't the main culprit for this problem. While a bad loss setting could affect performance, it's unlikely to cause this persistent majority class prediction by itself. We can rule this one out. If my features are super similar, highly correlated, this creates multicollinearity. It makes it tough for my model to separate them and figure out their individual effects. This could hinder model performance, potentially contributing to the issue. However, it doesn't automatically lead to the model only predicting the majority class. So, this one is less likely. I'm looking at a problem where my SGDClassifier model, a machine learning model used for classification, keeps predicting the most frequent class, regardless of the input data. This is a common problem, and I want to find out why. A very large ALPHA value means I'm using strong regularization. This is like adding a penalty for large weights in the model. Too much regularization simplifies the model so much that it ignores the input features and defaults to predicting the most common class. Think of it as forcing the model to be too simple, so simple that it loses its ability to learn the nuances of the data. If I have way more examples of one class than the others in my data, the model will try to minimize overall error by just predicting the majority class every time. It's like only seeing one type of apple for your whole life. You'll assume everything is that kind of apple. To fix this, I'll need to balance the classes, give equal weight to underrepresented classes. The hinge loss function is common in SVMs, support vector machines, which are related to SGDClassifier. While it might affect the model's performance, it's unlikely to be the sole reason for consistently predicting the majority class. The problem is more likely due to other factors. Having features that are highly correlated, can make it hard for the model to distinguish their independent effects on the outcome. It might weaken the model's ability to predict accurately, but it's not a guaranteed cause of always predicting the majority class. I'll explain why each option could lead to the SGDClassifier, always predicting the majority class. Let's investigate each possibility one by one. A very large ALPHA means you're using extremely strong regularization. Think of regularization as a penalty for having large weights in your model. A huge ALPHA forces the model's weights to be very small, almost zero. This simplifies the model so much that it essentially ignores the input features and just defaults to guessing the majority class every time. It's like the model gives up on learning anything complex and opts for the easy, albeit inaccurate, path. If you have many more examples of the majority class than the minority class, and you don't tell your model to treat them differently, it will likely become biased towards the majority class. The model aims to minimize overall errors, and it does so by correctly predicting the majority class most of the time, even if it fails to learn well for the minority class. It's like teaching a child to identify animals, and only showing that child pictures of dogs. The child will always say, dog. Similarly, an unbalanced dataset could cause the model to always predict the majority class. Highly correlated features, multicollinearity, make it hard for the model to discern which feature is truly important. This can reduce performance but doesn't guarantee majority class prediction. It's a contributing factor, not a direct cause. The hinge loss function is used in support vector machines, SVMs, which are related to SGDClassifier. While a badly tuned hinge loss could affect performance, it's not the main reason for consistently predicting the majority class. I'm training a model called SGDClassifier, Stochastic Gradient Descent Classifier, in Sklearn, a popular Python library for machine learning. My model keeps predicting the most common class, ignoring other information. I want to figure out why this is happening. A large alpha means I'm using strong regularization. Regularization prevents my model from becoming too complex, essentially by making the model's settings smaller. Think of it like adding a penalty for large values. If alpha is too high, I might be oversimplifying the model and thus ignoring the input features, making it just predict the most frequent class. It's like I'm forcing the model to be too simple, and it gives up. My data has many more examples of one class than others. Without class weighting, the model focuses primarily on the majority class, because getting that class right is easier. It's like I'm showing my model a ton of one type of apple, and only a few of another. Of course, it's going to be biased towards the type of apple it saw more often. Imagine you're training a model to identify cats and dogs, but your dataset has 99 pictures of cats and only one picture of a dog. Without class weighting, the model will learn to prioritize the majority class, cats, because correctly predicting the majority class is much more probable. It will basically ignore the minority class, dogs. This is because the model aims to minimize overall error rate, so it learns to predict cat most of the time, and this leads to the majority class prediction bias. Pretty straightforward, huh? The alpha parameter controls regularization strength in the SGD classifier. A very large alpha means super strong regularization. Think of regularization as adding penalties for large model weights. With a huge alpha these penalties become overpowering, forcing the model's weights to become tiny. The model essentially gets simplified to the point that it can't learn any complex relationships from the data. Thus, it resorts to the simplest prediction possible, always predicting the majority class. It's like the model is giving up. Highly correlated features can cause problems, but it doesn't guarantee that your model will only predict the majority class. The correlation may make it more difficult for the model to discern the impact of individual features on the prediction and thus impacts the performance negatively, but it doesn't directly cause consistent majority class predictions like a very large alpha or an imbalanced dataset does. The loss parameter defines the loss function used during model training. Hinge loss is used in support vector machines, SVMs, which are related to SGD classifiers. While an incorrectly tuned hinge loss could affect model performance, it's not the most likely cause for always predicting the majority class. It's the regularization strength, alpha or imbalanced data that are more influential in the context of this problem.